For the second part of 9.2, we are now looking at integration with composite functions and products. And so a quick recap on what we saw in the last video. Anytime we had this type of a look and we were to integrate this, we said, well, let's follow the rules of adding one to our exponent, dividing by that number, and then dividing by the derivative of the interior function. And so in this case, the derivative of this function would be a, and that's where this came from. And so those were kind of the key steps on doing that. What you're seeing on these problems for today's section is there's an extra product thrown in here that's being multiplied times this composite function. So two ways to look at this. If you have taken calculus or are taking calculus, you probably can do without the u substitution, but it's one way to go. So let me just kind of quickly show you the two options for this. If you just look at it as the same way you did yesterday's stuff, then here's what that would look like. We would say, well, here's our interior function. We're going to have our exponent right here. If I add one to this, I get 5. I'm then going to divide by that number, so I'm going to divide by 5. I also divide by the derivative of the interior function, and the derivative of this function is 2x. So I'm also going to divide by 2x. So this became a 5. I got a 5 on bottom. I got a 2x on bottom. Notice that my 2x would cancel with this 2x. And so all I would have down here is the 5. Got the 5 right here. And that would be my answer. This is very doable without u substitution. The benefit of u substitution is to just help people organize their terms and what goes where. So here's how u substitution works, is we say, well, let's try to do a little simplifying and say, here's our interior function, so we're going to let u equal x squared plus 1. So that's what we're identifying first, is we're going to let u equal that interior function. So ultimately, we're kind of going for this look here. So I'm replacing my x squared plus 1 with u, and that's to do two things. One is to help you get a little simpler look. It's also to help you recognize this key feature right here that we did in the previous lesson, which is to take the derivative of the interior function and put that on bottom. And so that's part of this process as well. So if we were to say, okay, here's our interior function. Let's take the derivative of this. So we're going to do this as du in relation to dx. Well, the derivative of this would be 2x. So here's that statement right here. Now if I were to get dx by itself, so I'm going to multiply dx over to the right. I'm going to divide 2x over to the left, and I'm going to get this look here. So dx is equal to du over 2x. So now we can replace dx with that fraction. So going back to the original setup that we had here, we have our u replacing the x squared plus 1. We have du over 2x replacing dx. And now we have not only a little simpler look, but we've also forced ourselves to put the derivative of the interior function on bottom, like we're supposed to. And now we can do some cleanup from here. So now we're going to say, okay, well, let's recognize that this 2x can cancel with that 2x. We also need to recognize that to integrate, I'm going to add one to my exponent and then divide by that number. And so here we go with that look here. That should be a 5. And so now we're here, and now we just back substitute, and we say, okay, let's put our value for u back in and finish it off with this look here. So u substitution is certainly a helpful tool, but like I showed, you could do without it. Let me do one more of showing you both options, and then I'm just going to stick with u substitution. But again, think of this as 2x to the third plus 5 to the 1/2 power, first of all. And then if you just stick with the integration rules, we'd say, well, if this is a 1/2 power, I know I'm going to add 1 to 1/2, and it's going to become 3/2. I then have to divide by 3/2, or you could say I'm going to multiply by 2/3, same thing. But then the last step on that is to divide by the derivative of the interior function. Well, the derivative of 2x to the third is 6x squared. And so if I'm going to divide by 6x squared, let's recognize that that would cancel with this 6x squared. And so ultimately, if you kind of get to this stage right here, we can say, well, I divided by 6x squared. It canceled with the other 6x squared. So all I had left was to add one to my exponent and then divide by this number, which is what you're seeing right here. And that's it. And so you could do without u substitution. The key on this, though, is this x has to cancel with the derivative of this interior function for this to work. If that didn't happen, we would need some other process like integration by parts, which we don't get into in this class. And so this will always work for our purposes. With u substitution, we'd say, well, let's let u equal 2x to the third plus 5. So here we are identifying the interior function. Let's take the derivative of this. So we're going to say du with respect to dx is 6x squared. If I solve for dx, I get this look here. And now I can replace dx with that fraction. And I can also replace u with 2x to the third plus 5. So if you go back to right here, we're putting the u value in. We're going to replace dx with du over 6x squared. And now we're going to do our integration process from here. But we can start by saying, well, 6x squared cancels with that 6x squared. So all I really have is the square root of u. So let's just do the derivative, or sorry, the integral from here. And so we have u to the 1/2. We add one to the exponent. We then divide by 3/2, which is the same thing as multiplying by 2/3. And then we back substitute and put the u value back in to finish it off. Two things, don't forget the plus c. Also, you can leave it like this, but you have the other option of converting it back into radical form. Looking at number 3, and again, this is maybe a good place to stop and give one a try, using whatever method makes most sense to you. But again, taking a look at this, first of all, let's recognize that the x to the third plus 8 is our interior function. It is the more complicated of the two, which is usually your hint, but also recognize that if I were to take the derivative of this, I get 3x squared, which is what's going to cancel with that 3x squared. And so that also tells me I want this to be my u value, so that I can cancel out with this guy. So again, recognize that that's our interior function. So we're going to say u equals x to the third plus 8. We're then going to say, okay, let's figure out the derivative of our interior function. So the derivative of u with respect to x will give us this look here. And we can say it's 3x squared. I then get dx by itself. And I get this statement right here. And now we can do some u substitution. And so now we're going to replace x to the third plus 8 with u. So that's this guy right here. I'm also replacing dx with du over 3x squared. And now we can look at that and say, oh, well, we divided by the derivative of our interior function like we're supposed to. It cancels with that guy. So all I have is this. Well, think of this as 1 over u du. And we know that 1 over anything is the natural log of that function. And so we're going to say the natural log of u plus c. And now we can back substitute and put our u value back in to finish it off. One last problem down here. Only difference on number 4 here is we're going to be able to get a c value because they're giving us some extra information so that we can solve for c. So again, if you haven't done this yet, I encourage you to give this a pause and try this one on your own first. But here's how this would look. So we got a product times a composite function. So remember, we have to say a function within a function. And so right off the bat, recognize that our higher power, x to the fifth, this is where we want our u value to be, because if I take the derivative of this, I'm going to get 5x to the fourth, which is what we want to cancel out this x to the fourth. And so we want that higher power to be our u value. So we're going to say, okay, well, x to the fifth plus 1 is our interior function. So that's the u value. We're then going to take the derivative of this function. So du dx would be 5x to the fourth. And again, notice this is key. This x to the fourth is going to cancel out with that x to the fourth, which is why we're recognizing this as our interior function here. The 5 and the 10 will reduce, even though they won't cancel, that's fine. It's the x's that really need to cancel out. So if I were to now get dx by itself, which gives us this look here, I can now do some u substitution. And so now replacing the x to the fifth plus 1 with u, so that's where this guy's coming from. I'm replacing dx with the du over 5x to the fourth. And now we can do a little cleanup here. The x to the fourth will cancel. 5 can go into 10 2 times. And so that brings us to this stage right here. Now if we do the integral from here, we can say, well, let's ignore the constant for just a minute. The integral of e to the u is e to the u. So here we go. We got the integral has now been taken care of. We got the plus c. We can now back substitute and put in the x to the fifth plus 1. And now we can take the extra steps and replace x with -1, set the whole thing equal to 5, and we can solve for our c value. So here we are replacing our x with -1, setting the whole thing equal to 5. If we solve that, we get c is 3. And we can now replace our c value with 3 to finish it off. Here's the main thing that I hope you're seeing out of this. So I'm glad you're still watching. When we do integration with composite functions, one of the main things that people so often miss on this is that step of dividing by the derivative of the interior function. So when you did this, if you were to do this without u substitution, that's fine, as long as you take the proper steps. When I was looking at this, if I wanted to just do the integral from here without u substitution, we would say, well, e to the x to the fifth plus 1, well, the integral of that is still e to the x to the fifth plus 1, but then I have to take the extra step of dividing by the derivative of this interior function, so I now have to divide by 5x to the fourth. And so you can really get to the ending result pretty quick if you recognize those steps and put 5x to the fourth on bottom and say, well, this x to the fourth now cancels with that x to the fourth, and you can go from there, and it's very doable without u substitution. But the one good thing about u substitution is it forces you to divide by the derivative of the interior function in this stage right here. And so that's kind of the one really major benefit that I see from u substitution, is that it forces you to take that step when so often people forget to do this. They will look at this problem and they will say, well, the integral of e to this is just e to this, and then they throw a plus c on it, and then they're done. And they totally forget the step of dividing by the derivative of the interior function, which would then cancel with this, and there's so much more to doing that. If you forget that step, you're falling way short of coming up with this look here. And so that's the one benefit of u substitution. But whatever works for you is best. So please, again, as always, come on in and get some help. If you'd like me to go through one of these one-on-one with you, I'd be happy to.